Okay, here we have the error handler that we're setting up for the session. Make sure that gets set appropriately so that it'll get called. We open up our serial connection to the device. Quickly do a garbage collect on the remote device just to both clear out anything that was in there before and also to find out how much spare memory it might have. Next, take some of the modules that are registered on the target and set up some proxies so that when we set up some code here, it won't fail when it doesn't find those modules registered locally on the laptop. Set up the CAN bus at 1 MHz. Send out a message to turn on a particular device that we're going to control. This next chunk of code here is all pretty much for printing out responses to requests for different parameters over the CAN bus. Fire off a couple of those requests after we start up just to make sure that the device is in a state we expect it to be in. And here's the more interesting part. This function here is going to be used as an iterator. And what it does is it returns a function that has a local value I associated with it that it can increment, and as it's successively called by a generic for loop, it will output the summation of two sinusoids, which will be used for describing the motion of the device. So we have that, and then we also have this function oscillate, which basically loops over this previous function, starts up a timer, sends out a command for where it needs to move, including the step size, since the commands are sent once every 10 milliseconds. It needs to know what to do in between those windows. Then we take the current position that we've gotten from our iterator, set that to our last position to allow this calculation to take place. Send a command to over the CAN bus to make it act on this new motion information, and then we put another delay here to pad out whatever's left of 10 milliseconds for this window, so that this loop will run through once every 10 milliseconds. Now, we've defined these functions locally. They're not actually set up on the microcontroller that's running eLua, but we're going to do that by saying slave.positor equals positor. So it sets this remote global to the local global, and then we do the same for the oscillating function. So those functions are now registered on the remote target, and when we finish with all that, we can send a command to oscillate at about 1 Hertz for the primary sine wave with an amplitude of 15 degrees, and do that for 10 seconds. So we're going to give that a try. So I'm just running a local instance of Lua. This is not running on the microcontroller itself. It's going to be sending that using this RPC code, and it's loading up this previous file called CAN test. So fire that off. Sends back that configuration information. And you can see it is oscillating back and forth. I'll do that again. And this is code that's actually running on the microcontroller, which you can see here. It's an STM32 microcontroller with a CAN adapter and transceiver attached to it. So one thing that's neat about this is that we can call this function on the remote side, different parameters, running with a higher frequency, say 5 Hertz. Or 2 Hertz. That's again for the main wave. There's also a secondary sine wave that's being summed with that one. Decrease the amplitude. Or in this same session that we have right here, you could even redefine the function. Say we want to remove that extra sine wave that's being added to the original one, so it's just a pure sine wave. Take that function, could reload this, but I'm just going to paste it in here, redefine it, replicate that back to the target, so it picks up this new function, and now when we run it, it's just using the single sine wave. Run this again. It's an amplitude of 15 degrees. Try that again with 3 Hertz. About an amplitude of 3 degrees. So what's neat about this is that we can modify functions that are running on the microcontroller. We don't have to be sending data over a link to it constantly, and we can arbitrarily change these functions whenever we want to update the behavior of the device. So it gives us a bit more flexibility and a nice and easy environment in which to debug the behavior of programs.